I've been working on a project called Clobber, which is a Clojure-Powered editor for text and code. And this is a talk that covers some background about what Clobber is and what it means to do, and also how it works under the hood. So for the agenda today, we'll be talking about some of the design goals of Clobber itself, give some background knowledge for understanding how it works, cover some of the tools of the trade, and basically the libraries that are used by Clobber, give some code examples to see how that works in practice, and at the end, I'll give a status update and talk about future work. So the design goals for Clojure was that I wanted a full-featured code and text editor. I want a first-class Clojure mode that I can use to write Clojure in full-time. A idiomatic Clojure API that makes it comfortable to work in from Clojure, full Unicode support, and provide a basis for additional modes in the future. So basically, any type of text editing that you would like to do, formatted text, other languages, configuration, writing notes, markdown mode, et cetera, et cetera. I would like to be able to support those in the future without rewriting everything from scratch. So if you're going to write a text editor, the first thing you need to do is figure out how to represent text. For this talk and for the design of Clojure, we're basically going to assume Unicode and UTF-8. Those are by far the most common pair of ways to represent text. And our first vocab word for today is grapheme cluster. So grapheme cluster is a user-perceived character, and it's kind of a landmine trying to describe these things because some of these words both have conceptual meanings and particular implementations that have different connotations. So in particular, character itself is an overloaded term and is very context sensitive, so I'll try to stay away from it. But grapheme cluster is when you're looking at text, kind of the individual unit. And we'll have an example that will hopefully make that more clear. And the next vocab word is Unicode code point. So its literal meaning from the Wikipedia article here is at a particular position in a table where the position has been assigned a meaning. So there's a Unicode consortium, and there's a list of defined code points where they have a large list of these numbers, and then the consortium decides what they mean, and then everybody kind of follows along with the standard. And one thing to point out is that a grapheme cluster may extend or may require multiple code points to represent. In fact, there's a zero width joiner where you can stack as many as you want, and you can have an arbitrarily long grapheme cluster. So as many, a million code points that all collapse down to one user perceived character. So that's something we'll have to take into account if we want full Unicode support. And then the last vocab word for the slide is UTF-8, which is a byte encoding for representing Unicode code points on a computer. Unicode has allocated, I think, 21 bits worth of code points. You can represent a Unicode point as an integer, as 4 bytes. The benefit of UTF-8 is that many code points can be represented with fewer than 4 bytes, so it requires less space. And that's why UTF-8 is a common byte encoding. So yeah, as a programmer, sometimes it's easier to understand things just by, show me the code. So here's the code. And so we have this text here, and you can see that it's one grapheme cluster. And when we count it, it's one grapheme cluster. But it is 7 code points. And here, this little snippet of code will show you the first code point, the first 2, the first 3, up to the all 7. And you can see that the code points combine in a non-trivial way into grapheme clusters. And so as a text editor, you want to make sure to, if you're deleting a user perceived character, you need to delete all of the code points that are associated with this one grapheme cluster. And just for completeness, we can look at the number of bytes. So it's one grapheme cluster, 7 code points, and 25 bytes. And we can also look at the length. So if you represent this as a Java string, you can ask its length, and it's 11. So where does that number come from? So in Java, the way to represent text, the primary way to represent text is strings, and strings can be thought of as sequences of characters. And so Java has a car primitive and a character class, and both of these are 16 bits. And you can see this big long quote at the bottom where they basically say, look, when we did this, Unicode said these the way to find characters are using these 16 fixed width 16-bit entities. It's not our fault, but nonetheless, we have this problem where 16 bits is not enough to represent all the text that we would like to represent on a computer. And so a code point may be one or two code units. And the way it's defined, hopefully, they thought 16 bits was enough and it wasn't. We now think 21 bits or maybe 32 bits is enough. So, we'll see. But for now, code points are 1 to 2 code units. And this is a little bit of incidental complexity. I think if this was designed today, we wouldn't end up with these, there would be no such thing as code units. But for backwards compatibility, we have to take on this incidental complexity. And I think it's worth it because there's a lot of Java libraries that work with strings. There's a regex regular expression library in the standard library that we would like to use. And so taking on this incidental complexity is this thing that we're taking on because it gives us access to more features that we want. So I'm repeating myself a little bit here, but this is really important for understanding how to represent text is that I think of it as a ladder, whereas a graphing cluster is one or more code points. And then either you have code points that are represented in code units, or you may be representing code points as bytes. And so a code point is 1 to 2 code units, and a code point can also be represented as 1 to 4 UTF-8 bytes. So let's look at some of the tools of the trade. So like I said, if you're representing text, you need some data structure to store it, and we use Bifurcan's rope for fast immutable string manipulation. We have TreeSitter, which we use for syntax highlighting, code navigation, structured editing. We have ICU4J, which helps us turn code units into graphing clusters. We have the Java standard library with all the functions that work with strings and regular expressions. The way Clobber visualizes text and does text rendering is through a C++ library called Skia, which is the same graphics library that Chrome uses to visualize all of its text and HTML. So it has really great support for a lot of different platforms, as well as it also handles a lot of the crazy Unicode stuff that we may want to represent. And then Clobber, which is this library here that we're talking about, which is a code and text editor. So for each of these libraries, I also listed the representation that those libraries use. And so you can see, so Bifurcan's rope is mainly in code points. There is some support for code units, but it's primarily code points. TreeSitter does everything in byte indexing using byte indexes. IC4J and the rest of these all use code units. And then the text editor itself wants to work in graphing clusters, and it also wants to work with like line numbers, rows, and columns. And so a big part of the research for putting all this together was figuring out how to get all these libraries to talk to each other. So keeping in mind how these different libraries represent text and getting them to talk to each other is important to keep in mind. So just a little bit more background on some of these libraries. So Bifurcan Rope. So Bifurcan is a Java library by Zach Tellman, and it provides a mutable data structure for text. And so there's already a way to represent text in Java, which is the string. And the reason we want a different data structure is that we want fast concatenation, insertion, and removal. Basically, all the text editing operations add and remove small chunks of text. And it's pretty slow with the built-in Java string. And so Bifurcan's rope is a way to do that more quickly. And one thing to point out for those that are curious is that if you Google rope, then the Wikipedia page will show you specific algorithms But I don't know if rope is actually the best name for this data structure because it's actually closer to the persistent data structures like persistent vector and Clojure. And so if you do look at the implementation, you'll notice that it's actually not like the rope implementations, but closer to persistent data structures. Like I said, it has built-in support for code unit and code point indexes. I added support for indexing by byte in order to make it interoperate with some of these other libraries more easily. And it had a way to provide to turn a rope into a car sequence, but I changed it so that ropes are car sequences. And that means that these ropes, a lot of Java libraries actually don't take in strings, they take in car sequences. And so that means that the rope itself can then just be passed like a string to many of these libraries. And in the future, I think it may be worth, for performance reasons and for convenience, to add support for indexing by a graphing cluster, being able to grab, rows or lines 10 through 20 and search for text by its column number. The next library to talk about is TreeSitter. So TreeSitter is a fast incremental syntax parser with wide adoption. It was originally built for the Atom text editor from GitHub. I think primarily it's used for syntax highlighting these days, but it has support for a wide variety of languages. There's parsers for dozens of languages, and the way I've been consuming it in Clobber is there's this Java library that wraps the C library that TreeSitter has called TreeSitter NG. And for Clojure's parser, I use this TreeSitter Clojure repo, which has been really great. And it provides a TreeSitter grammar for Clojure. So again, let's look at some of the code. So there's some boilerplate for parsing strings with the TreeSitter library that I've put into this utility function. So we get back a TreeSitter tree here. When you parse it, the way TreeSitter parses your text is that it turns it into an abstract syntax tree. And the root node is always source. And you can see from parsing this string here that there's a vector literal, and then the vector literal has two children, which are the num literal, the keyword literal, and the keyword literal is divided up into its name. Keywords can be namespaced. And there's also this utility for getting the nodes. And so let's look at the datafied version of these nodes so you can see what information these nodes have. So we'll look at just one of these nodes. And like I said before, everything is indexed in bytes. You get the row and column. The column itself is indexed in bytes, which isn't usually that helpful, but it can be useful for measuring white space because white space is often defined in ASCII characters, and ASCII characters are a case where there's one byte and one code point per grapheme cluster, so those all match. And you can also see the type for the node. And so this is really helpful for syntax highlighting as well as structural editing and navigation. The next library that we'll talk about is ICU4J. And ICU4J helps you turn code units into grapheme clusters. So as language evolves, Unicode Consortium will put out new updates to the Unicode specification. That may include new code points, and it also includes these tables for how to turn code units and code points into grapheme clusters. And so this is not something I want to spend time and do, and that's why I use this library. I mainly only use this one class, break iterator, which is a drop-in replacement for a standard java.text.break iterator, which is a Java standard library class that has the same interface. And I think it's worth asking, it's fair to ask, why not just use the break iterator that comes with the Java standard library? And there's a few reasons. So the first is that depending on which JDK version you are using, the built-in java.text.break iterator doesn't convert code units into grapheme clusters. It actually counts something else. I don't remember what it is. I think it may be code points. but it doesn't give us grapheme clusters, so that's a problem. Another problem is that at least with the JDK versions that I tested, the break iterator would, if you give it a string, it will immediately scan and parse the whole string. And this is really bad because as a text editor, you're doing a lot of editing. So each and every keystroke, you don't want to reparse the whole file and partition it into grapheme clusters. We want to be able to do everything incrementally. And so we're not reparsing the whole string all the time. And the break iterator from ICU4J does just that. It does it incrementally. You can give it a new string. It won't reparse everything until you ask for specific indices. And the other benefit of using this library is that, like I said, Unicode Consortium comes out with new versions, and it's easier to bump your library version than it is to bump your JDK version. You may not want to wait for the JDK to get updated with the latest. And then for testing, it's also really useful for, you don't necessarily want code that is dependent on the JDK version and gives you different results. That's kind of annoying for testing. So yeah, let's look at some of the code here using the break iterator. I'm not going to go over this class, but you can see it's very Java-y, and you can iterate through and count grapheme clusters. So that's one way to do it. And so you can see this string has 20 grapheme clusters, 43 code units, and 89 bytes. But the typical way to use this in the simpler example here is you can create a break iterator for a string. And so if you want to know, if your cursor is between A and this rocket ship, and you want to know how many code units to jump to get to the next grapheme cluster or get across the grapheme cluster, you can use this following. And so you can see that after index 1, to get to the next grapheme cluster, you need to go to index 3. And so if you do a substring here, you actually get the rocket, whereas if you do it naively, you can get garbage. And so this helps us be Unicode aware. And just like you can get the next index, you can also get the preceding index. And so this helps us move the cursor around, delete forward, delete backwards, and making sure we're deleting full and whole grapheme clusters rather than partial, code units or otherwise. So that's the background. We finally got getting to Clobber itself. And so this is the structure of the repo. So there's this util namespace, but everything else is in these modes. And so there's this base mode, which is text. And the way I think about it is that Clojure mode is kind of like text mode, but with a few additions like par-edit. And then another design goal was that I want a full data-oriented API that's headless, that doesn't require a user interface. And so all of the UI code is in its own separate namespace. But editing, Clojure editor UI is like Clojure mode, but with just a few UI specific things. And I've started work on Markdown. It's a work in progress. I basically just have a Markdown editor with text mode and preview, but that's still a work in progress. And so hopefully that will be available sometime in the future. And the main data structure, the data-oriented way to represent an editor is with a map in Clobber. And the editor can have whatever state is needed for your editor. So if you're a UI editor, you probably want more state for storing, keeping track of things. But the very basic editor will have a rope, which represents the text. It'll have a cursor. And if it's a code, it's probably going to have a tree, like a syntax tree. If you're just editing freeform text, then you may not have a tree. But these are the three main attributes that you'll find in the editor map. And the cursor, as you can see, will, for Clobber right now, maybe we can push some of this complexity into the rope data structure itself. But for now, the cursor itself has the byte index, the code point index, the code unit index, the row, and the column. And so a lot of the work for most of these functions is just calculating the correct, updating the cursor and calculating the right index, and so that all these different libraries can interact with each other, because depending on what information that you're trying to use from the tree or from the rope or otherwise, you may need um, these different offsets. So let's take a look at what that looks like. So you can see the editor here has a cursor and a rope, and you can use it. So the text mode namespace has a bunch of functions, and just about every function in that namespace is a function that takes an editor, maybe some additional arguments, and returns a new editor. And that's most of what you do. And even the UI itself, when we get to that part, you'll see that it's really just mapping user inputs into these functions that take and return editors. And so as an example here, we create an editor, we insert the string, which puts the cursor at the very end. We move to the beginning of the line, we delete the character forward, and then we replace it or insert T. So this has hello here, hello there with a capital T. And then Clojure mode, like I said, is pretty similar to text mode. You can use all of the text commands, but you also have access to these Clojure editor commands, which let you do structural editing and navigation. So we insert this string here, we go to the very beginning, we go forward one, we slurp in these three values, we add new lines, and as you can see, the new lines get added, and also the indentation follows Clojure standard format. So if you've ever used rewrite CLJ, this can feel really familiar, where you're editing code, but in a syntax and white space aware way. And you can just add the functions in this namespace aren't actually really that special. They're just taking data, returning data. If you want to add extra commands, you just take this map and return a new map with the updated cursor and rope. So yeah, let's look at the namespace. So this is the text mode namespace. Let's look at this editor forward car command. And so you can, the default is to go forward one character, but you can also go forward n. This is really useful for other commands they may want to build on top of it. And basically we're using the break iterator to move forward and figure out what the new cursor is with the new byte index, etc. And that's most of the work. This is a little bit verbose. If you're building editor commands, in many cases, you're just going to be able to use the existing editor commands and work at a higher level instead of working with bits and bytes. And it's not necessarily a design goal to make this as pretty. It's, in fact, I'd rather make these base commands as fast as possible, because that means everybody who builds on them and the people who build on those, making these fast makes all of those functions faster as well. I think there's still room to improve there, but that's kind of the thinking. And so yeah, moving forward a character just means moving the cursor. And then we'll look at a slightly more interesting function, which is the self-insert command. And so yeah, it's kind of the same thing. We move the cursor when we insert the text, and then we call this helper function, which is editor insert. So let's look at that. And yeah, I'll jump to the punchline here. So you update the rope, and then you also, if there's a tree, remember that if you're in text mode, you may or may not have a syntax tree. And the way TreeSetter works is that the way the incremental parsing works is you give it these edits where you give it the byte indices and the row and column of where you're adding and removing text. You don't actually give it the text that you're doing. You just give it the edits, and then after you give it the edits, you tell it to parse, and then you can give it the old tree. And so if you don't give it an old tree, it will reparse everything from scratch. And if you give it the old tree, it'll do an incremental update where it gives you a new tree, but it only does the necessary work, the minimum necessary work to update the parse tree based off of the edits that you gave it. And all of this is kind of put in these helper commands. So as if you're going to write functions that work on these editors, hopefully you don't have to mess with any of this stuff, but um, you can now know that it's there. And so, yeah, we talked about text mode. So let's talk about Clojure mode. Clojure mode is similar to text mode, but with a few Clojure-specific commands. So this is the key map, which is a mapping of, you can see the Emacs influence here, but these are basically key bindings, and they're really just mapping the key binding to the editing operation. And so you can see most of these are, a lot of these come from text mode, but there are some specific overrides and replacements and additions that are Clojure specific, stuff like indentation. And yeah, that's, oh yeah, and I was gonna look at these highlight queries. So you can see that there's these highlight queries, and these are, this is a query syntax from TreeSitter. And so one of the cool things about TreeSitter is that there's parsers for dozens of languages. There's also these highlight query things for a lot of languages. And so you can see there's numlet, which is a syntax node type, and you give it a name. Here's the list, constants, you can group them. And then down here we have colors, which map the syntax name type to colors. At first, I was really excited by this. I was like, okay, great. We have free syntax highlighting for dozens of languages or whatever it is. What I found, I think, depending on the language, that may or may not be true. But I also learned that the query syntax is not fully implemented in the C library. So there's some things that just can't be expressed in the query language that's available to the C library that is being used under the hood. And also, depending on your language, so the syntax for Clojure is actually pretty simple, but there's not really a way to capture, so def here is highlighted, but you're not supposed to highlight it if it's just a free floating symbol. If you put it in a list and it's the first thing, you can highlight it, but if it's the second thing, it's no longer special. And it's not really something you can capture in the query syntax language. So I was super excited about it, but I'm less excited now that I realize that it may not be the best way to give first-class syntax highlighting for a lot of languages, but it's a really great place to start. So who knows, we'll see. Maybe the C library will get better support in the future, but that is something that I'll have to figure out as other languages get introduced. Okay, so yeah, we looked at the text mode and Clojure mode. This is the UI, which is in a separate namespace. And let's see, look at my, and what we were going to look at here was the key bindings. So the Clojure mode added quite a bit on top of text mode, but you can see the UI adds very little editing operations that are just in the UI. It's mostly just the Clojure key bindings plus a few UI specific things. And so you can see there's really only one editor command, and then these keywords are actually corresponding to effects. So let's look at tap editor. And these effects can affect the editor itself, but you can also do side effects like saving files. Here we have saved editor. We can look at what it looks like to tap this. So let me tap it a few times so it's actually on screen here. And so this is the editor map. And as I said, you have the tree, the rope is here as well. But there's also a bunch of extra information that is really specific to the UI, and it's a map. You can combine these things together. These should probably be namespace keywords, but you can compose more information about the editor itself and you can just represent it as a map. Like here we have the font families. So you can change the font. And a bunch of other, like the history, which is really useful for undo. Anyway, there's a bunch of stuff here that is useful for the UI. And depending on the mode that you're working on, you can just put it in the map. These things just compose together. And the other thing I wanted to show here is editor to paragraph. And so for text editor, most of the work is, so there's this paragraph view. And so you have the data that represents your editor, which has a bunch of extra information about what you want to display. And so it's really just a pure function of the editor to a view that is the primary work of the user interface. And so most of the way to represent a code editor is via formatted text. And so paragraph, you give it a list of formatted text, and we layer our style text together. So there's this function that does all the styling based off the syntax nodes. There's the selection style, which layers in the selection highlighting. There's a debug selection, which I use for testing out new editing commands. And then there's a highlight search, which has this sort of highlighting here. And all of these get layered on top of each other. And so you can represent almost all of this as formatted text, but if you wanted to do some other crazy user interface stuff that represents the code, you can do that as well. And you're just taking it's just data transformation of taking the editor in and returning a view. And yeah. So I got some questions about how extension will work, and I don't pretend to know exactly what the best API is for this, but I do have a few thoughts on kind of where I intend to go. And the mantra that I typically have in mind is make the common case easy and the complex case possible. And I really believe the best way to do that is to provide a lot of simple pieces. And basically, if you make it easy to make new things via composition, then you can also package up those things that you made to make it to target common use cases. So, for example, it's probably pretty common for people to want to be able to adjust the theme of an editor. And so if it's easy to layer in your syntax highlighting, then it's easy to provide a simple way for somebody without learning, all your full API and how everything works to just provide a new theme. And so that's kind of the way I think about it. And then I also want to be able to, you also want to have simple pieces. So if you want to make a different kind of editor, like a different mode, or you want to do reuse one of these editors in a different context, like a REPL or any sort of wacky project that you might have in mind that does text editing, you can reuse a lot of the simpler pieces and compose them together to make something new. And I also want to avoid plugins at all costs. I feel like especially in the user interface world, but in general with user interfaces and an object-oriented code, you get this thing where it's so hard to build anything that once you have somebody went through all the effort to actually build a code editor, it needs to have all the features. And then if you want to do something different, you need this plugin API, and maybe it'll call you at the right time, and maybe it'll give you the right information. And maybe if you return something, it'll do something with it. And maybe if you want to do something different, they had that in mind when they were building the API. And I just don't think that's a great way to do reuse. It sounds like a total mess. So I think a functional approach can make it easier to build. If you want to do something different, you don't have to start over. And I don't think anybody's really excited about configuration. I think for things like theming and key bindings, there are some limited use cases where that is convenient. But in general, I think the best way to do it is to provide simple pieces and let people build the things they want by composing the things that are there with some slightly new and novel features. And just to talk a little bit more about the user interface in general, it's a design goal that the user interface is completely optional. So you saw the data-only version, the headless command. You shouldn't need to fire up a virtual frame buffer and start shooting pixels everywhere to use this thing. You can use just the data. And there's a couple of reasons for that. So one is that it's really great for testing. You can use it rewrite CLJ in many cases. Another reason is that to support multiple implementations. So if you want to, build I have my own intuitions about what I think is good for a code editor. Somebody else may have different intuitions, and these things can coexist, and you can still have a lot of reuse. And so the data representation of what is editing and having an editor and adding and removing and moving the cursor shouldn't you should be able to reuse these things regardless of kind of the UI that visualizes it. And so the other thing I kind of wanted to mention was that since these things tend to get coupled together, so for example, Sublime is a code editor, but it also has user interfaces for like project structure and navigation, file selectors, a terminal, inspectors and stuff like that. And Clobber is really trying to focus just on the text editing capabilities and the code editor itself. And it's not that you don't want to be able to have a file picker and a project viewer that is tightly integrated with the code editor. You can do that, but you still want to have access to these simpler components and then compose them together. And at least for the built-in UI that I'm working on, I'm pretty fond of this UI library called Membrane. And like I mentioned before, the graphics library is Skia, which has been a really great library because it has really great support, performance, works on a lot of different platforms, and it's been working really well. So speaking of which, this is the Membrane wrapper for Skia's text handling. And the basic API is this one function called paragraph, where you can give it a sequence of text, and each of these text pieces can have its own styling. So let's turn on the Insta REPL, and you can see that there's these different text snippets, and they all have different styling, and you can use whatever styling you want, like background colors, italics, font families, bold, underlining, squiggles, you name it. It's probably supported by Skia. And the other really helpful thing for this library is that it gives you really great access to the layout information for the text. So this is the paragraph that you just saw above, and you can also give it the indices into the text, and it gives you the rectangles for where that specific text appears. And so that may seem kind of boring, but in a lot of different environments, getting actual layout information for the individual units of text is really a huge pain, especially if you have like lots of different types of formatting and fonts, and it can be quite difficult. And it's really important for building really dynamic, interactive user interfaces. And so this is another function where you can give it the screen coordinates, like X and Y at 10, 20, and then it gives you back the coordinate position in the text. It also gives you this affinity, which I won't really explain, but so you can convert text into screen coordinates and screen coordinates back into text. And then another really cool thing that is built in, and so you can see this view here where there's like an arrow to the right, there's an arrow to the left, and then there's this placeholder. And in this placeholder, we've put this checkbox. So a placeholder can have a width, a height, and alignment. So you can see that if I move this to the top or the bottom or the middle. And this is a static view. I mean, you can change it here in the code, but it's actually pretty trivial to put in a dynamic view here. And why I think this is cool is that, so you may have noticed that up here when I drag this, that I get the coordinates for where to put this. So like if I move this parentheses, you can see this like will follow it. I get these coordinates from these functions here, but the placeholder, what's cool about that is you can actually place dynamic elements in the flow of the text. So, as this grows, instead of just getting drawn on top of each other, getting layered on top of each other, you could have it so it's in the flow of the text so that everything below would move down. So I think that's a really cool way to make your code more interactive. And Yeah, I think there's some, and the other cool thing is that you get the screen coordinates from the layout information, and you get the text coordinates also from this library. And then with tree sitter, you also get the text coordinates for the different syntax nodes. So if you're building complex user interfaces, you can see where this is going. Is that basically if you want the mouse to interact with syntax directly, you have all the tools that you need to do that. And so if you wanted to, let's say you have an editor and you want to replace all the booleans with checkboxes, that's maybe not a great idea, but you could do it, and maybe I think that would be fun. Um, so yeah, this is the path to being able to make code editors that are do way cooler stuff than we're kind of probably accustomed to. And so, just kind of a fun example. Spent a bunch of time working on indentation and like boring stuff. I wanted to do something that I thought was interesting. So let's start on the Insta REPL here. I'm gonna write some code, so bear with me. Um, okay, so hopefully this looks kind of familiar. This is the classic FizzBuzz, and we can try some different numbers here. Um, we can give this result a name. Look at the result here. And so as you can see, when I hover over the syntax elements, it shows the deepest child node in the tree. So here I'm hovering over 0, which we can see is a symbol name. We can hover over this list. Keyword, this bigger list. It also works with like sets and vectors and all the other stuff. And then if we click on this, so we know in Clojure that a function takes a list of arguments and then has a return value. So so I've selected num, so it's in this list here, and we put the cursor on the return value, we can do make fun, which what that does is since we have access to all of the syntax information and in the code, we can trace the result FizzBuzz from the arguments, and we can just automatically put those in a function. It's just a pure function. So you can go from a concrete implementation to an abstract implementation, and we can give it a name, FizzBuzz, and then we can see what the result is for this lazy sequence of numbers. And yeah, looks like it works. So yeah, the current status of the project is that it's a total mess, still a work in progress. There's still plenty of work to do, but I am using Clobber as my primary editor, although it's not self-reliant yet. Like I don't quite yet have support for like editing JSON files, which is something that I need to do on a daily basis. But all the features that I've added to Clobber recently have all been done using Clobber itself, which is really satisfying. Adding a new key binding that does something that's in the specific context of the problem I'm working on is really satisfying, and just giving it a Clojure function that, call this function when I do this key command, but give it the context of my editing environment just feels really powerful. I still need to upstream changes to third-party libraries, and then I have an integration with easel that hasn't been merged yet. If you don't know what that means, don't worry about it. And I got some questions on Slack, so thanks for everybody who posted questions there. How heavily does it rely on the JVM? Would it be portable to Babashka, for example? So the short answer is that it uses quite a bit on the JVM. That may require some work to port to Babashka. So the rope library is all Java. And so I think that wouldn't be that hard to add if it was a useful feature. But ICU for J and then tree sitter are more difficult to add. I don't think it's an insurmountable amount of work, but yeah, it would require some effort to make that happen. So maybe in the future, are there any support for different languages? So right now I'm really focused on Clojure mode. I'd rather have one great Clojure mode and no other modes than like one okay Clojure mode and like half a dozen okay other modes. But I would like to have future support for other languages. Um, Somebody asked, Ben Celez asked a question about unison and arbitrary. What facilities exist for arbitrary rendering, especially around metadata? So as you can see from the paragraph slide code example, is that you have all the tools you need to do all kinds of crazy stuff. And so I'm looking for, I've been doing a lot of boring stuff. I'm looking forward to just trying some experimental um, interfaces for working with code and seeing what sticks and what works. So I think the pieces are there. You have access to a full UI library with like 2D graphics, maybe 3D graphics in the future, and all of these things can get integrated and work together with each other. And so I think that was kind of the whole reason for doing this, working on this project, is that I think it's, the JVM has these crazy cool features like um, multi-threading that's like high quality. It's got a world-class garbage collector. It's got a huge variety of libraries. I've got access to networking and 2D graphics, and I really like using Clojure. And working on a text editor isn't trivial, but it's a relatively easy problem compared to making 2D graphics first class in Emacs, or re- using Clojure in Emacs instead of eLisp, or adding multi-threading and multi-processing and um, a world-class garbage collector to Emacs. Like those problems are near impossible, whereas building a text editor is, um, as you hopefully every one of you can now build your own text editor. So that is kind of one of the reasons why I think why I'm excited for this project. And so future work, more modes, continue to improve Clojure mode. There's a lot of simplification that can do. So I've been as I work on more modes, I've been trying to refactor and simplify the API, and I think there's still a lot of work to do there. I like to upstream the changes so to make those available. And I think there's a lot of low hanging fruit. So people have asked me about like what kind of features are possible, and I think a lot of the features are actually just not that hard. It's just that there's a lot of it's hard. The benefit of Emacs is that it's been in development for decades and has a lot of has a lot of features that are really really great. And so it's going to take a while to play catch up. But I think a lot of the features that are missing, most of them are now kind of not that hard to do anymore. So hopefully there will be a lot of progress coming soon pretty quickly. So anyway, that's what I've been up to. Thanks for listening. If you made it this far, thanks for watching, and have a great day.